Welcome to the trail. When we look around a peaceful river or a quiet forest, everything naturally finds its balance. Solving math equations works exactly the same way. It is a clear process of restoring balance, one step at a time. Today, we are exploring expressions and equations. We are going to look closely at long linear equations, where the variable shows up on both sides, and we will work through examples that include fractions and decimals. The overarching strategy for these complex problems is simple. We look at what's scattered across the equal sign, and we carefully gather our numbers, the constants, and our variables together. Mastering this specific process, solving linear equations with rational coefficients by collecting like terms, is the complete full equation solving skill. Here is our first equation on the path. 5x minus 3 equals 2x plus 9. Our first move is to focus entirely on gathering the variables. It can be tricky to decide which side to move them to. A reliable method is to move the smaller variable over to the larger one, which helps avoid negative numbers. So we subtract 2x from both sides, leaving us with 3x minus 3 equals 9. Now we gather our constants. We add 3 to both sides to isolate the variable term, which gives us 3x equals 12. To completely isolate x, we divide by 3. That leaves us with our final solution, x equals 4. Equations with variables on both sides are systematically solved by always collecting the variable terms on one side and the constants on the other. Let's see what happens when the coefficient is a fraction. Here we have 1/2 x plus 3 equals 9. We start by isolating that fractional variable term. We subtract 3 from both sides, which gives us 1/2 x equals 6. Take a moment and think. What specific inverse operation do we need to undo a fraction and get a single whole x? We multiply both sides by the reciprocal. In this case, we multiply by 2, which gives us x equals 12. Fraction coefficients can be undone with the exact same inverse operations we use for whole number coefficients. Our final variation involves decimals. They behave entirely by the rules we have already verified. Our equation is 0.4x plus 2.5 equals 6.5. We begin by gathering the constants. Subtracting 2.5 from both sides leaves us with 0.4x equals 4. Dividing a whole number by a decimal works through straightforward division. We divide 4 by 0.4, and we find that x equals 10. Decimal coefficients behave exactly the same way as all other rational coefficients. The rules for balancing linear equations apply universally. We can organize everything we've covered into a reliable set of rules for any linear equation. The very first step is to distribute and combine any like terms. Next, you gather your variables to one side of the equation. Then, you use your inverse operations to balance the constants and isolate the variable. Finally, verify your work by substituting the answer back into the original equation. Internalizing these rules refines your equation solving and directly prepares you for systems of equations and high school algebra. Before you head back out on the trail, consider this. What do you simplify before isolating the variable?